So I am doing number 11 of the chapter 15 AP Physics homework, and it reads that three charges are arranged as shown in the figure here. Find the magnitude and direction of the electrostatic force on the charge at the origin, which is right here. So we know that the two red charges are positive and the one blue charge is negative, so I just wrote them here. And since these two charges are positive, and we know that positive force charges repel each other, it's going to cause this charge to go in this opposite direction. And since right here we're dealing with a positive charge and a negative charge, and we know that positives and negatives attract each other, it's going to cause this charge at the origin here to go in this direction. So it asks us to find the resultant charge, so we know that our resultant charge will be somewhere right here in the middle. So using this equation to find the force that's given to us, the equation that's given to us to find force, we know that force equals K times the absolute value of charge 1 times charge 2 all over the radius squared. That's not squared, my bad. Let me change that. Radius squared. So first, what we needed to do is convert all of our values to coulombs, since they're giving to us in nanocoulombs. So I googled it and I found that 1 nanocoulomb equals 10 to the negative 9th coulombs. So converting all these three values of the charges, I got these three values here. So now we can plug them into our formula to find our forces. So for force 1, we start with the K constant, which is 9 times 10 to the 9th. And then plug in the two charges involved, which are 6 times 10 to the negative 9th coulombs and 5 times 10 to the negative 9 coulombs. And we put that over the radius squared, which is 0.3 meters. That was given to us. We square that and plug that all into your calculator. You should get 3 times 10 to the negative 6 newtons. For the second force here, we do the exact same thing, but with the different values. So we plug in our K constant, which is 9 times 10 to the 9th. We plug in one of our charges, which is 5 times 10 to the negative 9th, and then we plug in our other charge, which is 3 times 10 to the negative 9th. And remember that when you put we have to use the absolute value of the charges, so although it's given to us and it's negative, when we put it in the absolute value, it comes out positive, so that's why it's positive here. And we put that all over the radius squared, and our radius here is 0.1 meters. And plugging that into your calculator, you should get this value here, 1.4 times 10 to the negative 5th newtons. So to find the resultant force, we can use distance and plug it into this formula. So we take this squared plus this squared should equal the distance, or resulting force squared. So doing basic algebra and the work of our calculator, you should get the resultant force as 1.4 times 10 to the negative 5th newtons. And then they also ask us, they ask us for the magnitude and direction of the force at the origin. So we also have to find theta here. So we can do tangent of theta equals force 2 over force 1. And to find theta, we can do the arctan of force 2 over force 1. So plugging that into your calculator, you should get 77.91 degrees, and that's how you find the magnitude and direction of the force at the origin. Thank you, bye!